Mathematics, the universal language of the cosmos. Mathematics is often perceived as an abstract field, full of complex equations and theoretical concepts. However, it's much more than that. It's the fundamental language of the universe, the code that underpins everything from the spirals of galaxies to the intricate designs of seashells. Mathematics is omnipresent, hidden in plain sight, governing the natural world and the cosmos. The universal language. At its core, mathematics is a system of patterns and relationships that can describe and predict the behavior of everything in the universe. From the orbit of planets to the growth of plants, mathematics provides a framework for understanding how things work. The Fibonacci sequence, one of the most famous examples of mathematical patterns in nature, is the Fibonacci sequence. This series of numbers, where each number is the sum of the two preceding 1, 0, 1, 1, 2, 3, 5, 8, 13, and so on, appears in many places in nature. It can be observed in the arrangement of leaves on a stem, the spiral patterns of galaxies, and even in the breeding patterns of rabbits. Symmetry and group theory. Symmetry is another key concept in the mathematics of the universe. It's about balance and proportion, and it's ubiquitous in nature. The human body, for example, exhibits bilateral symmetry. Our left and right sides are mirror images of each other. But symmetry goes beyond just aesthetics. It's a fundamental principle that governs the structure of everything from atoms to galaxies. In mathematics, symmetry is described by group theory, a branch of algebra that studies the algebraic structures known as groups. These groups encapsulate the essence of symmetrical objects and have applications in various fields, from physics to chemistry to art. Mathematics and physics. Mathematics is the language of physics. The laws of physics, which describe how everything in the universe behaves, are written in the language of mathematics. Equations like Einstein's famous E equals mc2 or Newton's laws of motion are mathematical formulas that describe the fundamental principles of the universe. Without mathematics, we wouldn't be able to understand or describe the physical world with such precision. Patterns in nature. Nature is full of patterns that follow specific mathematical rules. These patterns are not random, they often result from optimization processes that lead to efficiency. The golden ratio. The golden ratio, a special number approximately equal to 1.618, appears in many places in nature. It can be seen in the spiral of a seashell, the pattern of seeds in a sunflower, and even in the proportions of the human body. The prevalence of the golden ratio in nature is thought to be due to its properties of efficiency and aesthetic appeal. Fractals. Fractals are complex patterns that look similar at different scales. In other words, no matter how much you zoom in or out, the pattern remains the same. Fractals can be found in many natural objects, such as the branching pattern of trees, the structure of snowflakes, the jagged shapes of coastlines, the structure of blood vessels in the human body. The mathematics of fractals has applications in many fields, from computer graphics to modeling natural phenomena like the growth of plants. Population dynamics. Mathematical patterns also appear in processes such as the way animals move or the way populations grow. For example, the population dynamics of certain species can be described by the logistic growth equation, a simple mathematical model that captures the essential features of population growth, such as the carrying capacity of an environment. Mathematics and the cosmos. As we move from Earth to the cosmos, we see that mathematics continues to play a central role in shaping the universe. The orbits of planets, the motion of galaxies, and even the shape of the universe itself can be described using mathematical equations. Geometry of space. One of the most important mathematical concepts in cosmology is geometry. According to Einstein's theory of general relativity, space is curved by the presence of mass and energy. This curvature affects the motion of objects in space, causing them to follow curved paths or geodesics instead of straight lines. The mathematics of curved space is described by differential geometry, a branch of mathematics that deals with curves and surfaces. This field of mathematics is crucial for understanding phenomena like gravitational lensing, where light is bent by massive objects in space. Topology of the universe. Topology, the study of properties that remain unchanged under continuous deformations, is used to study the global structure of the universe. The shape of the universe could be flat, like a sheet of paper, or it could be curved, like the surface of a sphere. The mathematics of topology helps scientists explore different possible shapes of the universe and understand how these shapes could affect the behavior of space and time. The cosmic web. The distribution of galaxies in the universe is not random. It follows a pattern known as the cosmic web. This web-like structure is formed by the gravitational attraction of dark matter, a mysterious substance that makes up about 27% of the universe. The mathematics of the cosmic web is described by complex algorithms and simulations that model the gravitational interactions between galaxies and dark matter. Mathematical models and predictions. Mathematics is not just about describing patterns, it's also about making predictions. Mathematical models are powerful tools that allow scientists to simulate and predict the behavior of complex systems. Planetary motion. One of the most famous mathematical models is the model of planetary motion developed by Johannes Kepler in the early 17th century. Kepler's laws of planetary motion, which describe the elliptical orbits of planets around the Sun, were based on precise mathematical calculations. These laws not only explained the motion of the planets, but also allowed astronomers to predict the positions of the planets with great accuracy. Modern scientific models. In modern science, mathematical models are used to simulate everything from the behavior of subatomic particles to the dynamics of entire galaxies. These models are based on mathematical equations that describe the physical laws governing the system being studied. By solving these equations, scientists can predict how the system will behave under different conditions. Mathematical models are also used to explore scenarios that cannot be observed directly. For example, scientists use models to study the early universe, a time period that occurred billions of years ago. These models allow scientists to test different theories about the origins of the universe and make predictions that can be tested by future observations. Mathematics and future discoveries. The role of mathematics in science is not limited to what we already know, it's also a key tool for future discoveries. As scientists continue to explore the universe, they rely on mathematics to guide their research and help them uncover new phenomena. Dark matter and dark energy. One area where mathematics is likely to play a crucial role in the future is in the study of dark matter and dark energy. These mysterious substances make up most of the universe, but they cannot be observed directly. Scientists are developing new mathematical models to understand the properties of dark matter and dark energy and to predict their effects on the universe. These models could lead to new discoveries that revolutionize our understanding of the cosmos. Unified theory of physics. Another exciting area of research is the search for a unified theory of physics, a theory that would combine the four fundamental forces of nature into a single framework. This quest for a unified theory has led to the development of new mathematical concepts and tools, such as string theory and quantum field theory. These mathematical theories could provide the key to understanding the most fundamental aspects of reality. Artificial intelligence. Mathematics is also playing an increasingly important role in the field of artificial intelligence (AI). AI algorithms are based on mathematical principles, and advances in mathematics are leading to new breakthroughs in AI research. These advances could have far-reaching implications for science, technology, and society. Conclusion: the beauty of mathematical order. As we reflect on the role of mathematics in understanding the universe, it's clear that mathematics is much more than just a tool for solving problems. It's a way of seeing the world. The patterns and structures we've explored show us that the universe is not a random, chaotic place, but a beautifully ordered and harmonious system governed by mathematical laws. Whether we're studying the spiral of a galaxy or the structure of a seashell, mathematics reveals the hidden order in the world around us. It connects the smallest particles to the largest structures in the cosmos, showing us the unity and coherence of the universe. Perhaps the most amazing aspect of mathematics is that it's a creation of the human mind. It's a testament to the power of human curiosity and imagination that we can use mathematics to understand the universe in such profound ways. Every time we observe a pattern in nature or solve a mathematical problem, we're engaging with the same principles that govern the entire cosmos. The journey through the mathematics of the universe reminds us of the interconnectedness of all things and the underlying harmony of the cosmos. It invites us to continue exploring, questioning, and seeking to understand the mathematical principles that shape our world and our universe.